Hello everyone and welcome to the second video in this course, the OCR computing course. Today we're looking at topic number 2, which is all about the CPU. Very important topic. Make sure you learn everything in this video, rewatch it if necessary, and if you're revising on a schedule, make sure you may want to speed up the video using the option on YouTube. So let's look at what CPU stands for. Obviously CPU is an acronym, it's not actually a word, and it stands for Central Processing Unit. And those three words sort of describe what it does. It's basically the hardware within a computer whose sole purpose, the purpose of a CPU, is to process data. Pure and simple, processing data is what it's designed to do. And it's often likened to a brain, so quite a simplistic model of the CPU, model being just a way of describing it. A simplistic model of a CPU is as the brain. So if you look at all the components in a computer and match them up to a human body part, the brain is the most likely one for the CPU, because it controls what goes on in the computer, but it does this by processing data and instructions. So other hardware, which we'll look at hardware in a more detailed video, but your motherboards, like I would say, like a skeleton, sound card, maybe like your ears, etc. So quite a simplistic model. We're going into more detail. So it's also important to realise that the CPU isn't just a processor. So the problem is, and you may notice this in this topic, because I may unintentionally use some words interchangeably, definitions such as CPU and processor and words such as these, they are quite ambiguous meaning that they've got lots of meanings, because these words were sort of coined in the latter half of the 20th century, and as technology has developed, as computer scientists have sort of understood things more, as things get more complex, the definitions have changed and they've got more refined, but that still means that they're not watertight. A lot of things in computer science and computing aren't watertight. They have lots of meanings. Different people say different things for each word. So that's actually an advantage for the student, because examiners may be slightly more lenient with how you use your technical terms. So yeah, the CPU, you can almost think of it as a CPU being a unit, and it contains a processor. In fact, it contains lots of different types of, I won't go into it, but it contains lots of different sort of blocks that do certain things. So you've also got something called cache, which we'll look at in the next couple of slides. So it's not just a processor, it's several things rolled into one. And for processing data, so its sole function relies on 3 operations that it can conduct. So the first one is, and by the way, this works in a cycle. People may describe it as a processing cycle. The first one being fetching. So firstly, whenever it receives a request for something, so for example, if on my desktop I've got a Microsoft Word shortcut, if I double click that, the CPU will register this and it will go and search and look for the instruction that's been saved in the memory. Important to realise that it does interact with the memory here, so it will go and find this instruction stored in the memory, and then it will have to decode the instruction that it finds. Decoding meaning that it sort of sorts them into parts. So often when you in an exam get a complex problem, you'll often in your mind, or maybe even physically, you split it up into different parts, meaning that it's actually simpler to work out. So for example, a complex instruction, maybe not so much opening a Word document, it will sort of split it up into these different blocks in the CPU. So each block is sort of designed to do a specific function, and it will it will split it up, and each one will sort of work on it. Then it executes it. Executing in computer science means to run. Doesn't mean anything more sinister. Just means to run something. So the final stage is to execute it. All the different decoded parts will go together, and the instruction will be processed. It will be run. So for example, if the initial fetching of the instruction is to do a mathematical calculation, even something simple like 4 plus 5, the execution will result in 9 being outputted from the CPU. If this makes sense. If it doesn't make sense, go over it. Some of it's a bit difficult to explain, so maybe read over it. But this is actually what a CPU looks like in a computer. Often it'll be sat on the motherboard. It will have a large heat sink on it, usually to cover it up because it gets quite hot. It'll comprise of these different units. Okay, so I've just written a few points just to make sure that I don't miss over anything. It's important to appreciate that the CPU does actually interact with other items in the computer, such as the memory. Like I mentioned before, it what was the word I used? Fetches. mind blank there. It fetches instructions from the memory, so it does interact with other hardware within the computer. We'll look at memory in more detail later, but so this means that the CPU is actually not necessarily the only processor in the computer. There are actually processors in other hardware, such as a graphics or sound card. Again, we'll look at those in more detail later, but those processor cores in the graphics and sound cards focus on those specific roles. They don't necessarily interact with other hardware as much as the CPU does. The CPU is literally the integral part of that computer. It's in the middle of everything. You can look at it that way, hence the central nature in its name. So we're going to look at 3 characteristics of a CPU. First one being clock speed. So the clock speed of a CPU is the CPU does need a certain amount of cycles to execute instructions. So for each instruction, get my words out, a certain amount of cycles need to be completed. So the faster these cycles can be completed, the more instructions can be executed per second, and that is the clock speed. So you can think of a cycle being a complete circle. You don't necessarily need to know what a cycle is. It literally just means I probably won't go into what a cycle is. It's a bit more complicated. You just need to know that the clock speed is however many cycles can be completed per second, usually measured in gigahertz. And that's also an important thing to realise. They also are measured in gigahertz nowadays because processors are so fast. So a little more of a visual example of what I mean here. So if you have two processors, one's got a fast clock speed, the top one here has got a fast clock speed, the bottom's got a slow clock speed. The instruction going from A to B will be completed faster with a faster clock speed. Sort of common sense, so this obviously results in a higher clock speed, meaning that a greater amount of performance, because a higher clock speed means that more instructions can be executed per second, although this is on an individual instruction basis. So generally increased clock speed equals increased performance. So also need to look at another characteristic of a CPU, and that is number of cores. So a CPU can have multiple processors called cores. So you can think of a core being a processor. Like I say, a processor makes up a CPU. A CPU isn't CPU sort of isn't a processor. So here's sort of a diagram. So if this is a microprocessor just means it's all on one chip. This little green box is a microprocessor. You've got 4 cores here, and they each are separate, but they interact together to form the CPU. And basically these cores allow multiple instructions to be executed simultaneously. So instead of running one instruction at a time, each core can run one instruction at a time, which means at any given time 4 cores can be run. In this case, if it's 5 cores, 5 instructions could be run. If it was 2 cores, 2 instructions could be run, which means that if a program is optimized for this parallel computing, basically some programs won't be able to make use of these 4 cores. They'll only work through 1 core, but some programs such as a intensive video game or video editing software will often be designed so that these 4 cores can all be used simultaneously, which means that more cores is better. Basically, more cores means an increase in performance for multiple instructions. So to put this in context a bit, this is a question taken from a AQA paper actually, but it works with this specification. So it asks you basically to explain which computer will run instructions quicker. A quad-core processor with a clock speed of 2 GHz or a single-core processor with a clock speed of 4.1 GHz. So the answers I came up with for this, you can say either actually, quite crucially, you could say either. I would tend to say PCB, but PCA you could say because it's got 4 cores, meaning quad is obviously 4. It's got 4 cores which allow 4 instructions to be executed at the same time. That's all you really need to say to get these 3 marks. These 4 cores allow 4 instructions to be executed simultaneously. Or you could say PCB, and I would if I was in the exam I'd write PCB. This is because not all programs can handle these parallel computations. Not every program will be able to do this, so instructions won't be run as quickly for some programs, and the clock speed of B is higher than A, meaning that as each instruction can be processed more than twice as quickly. You can see this clock speed is twice as big as this one, so each instruction will be processed twice as quickly. I put some context a bit. Quite simple sort of questions you get on this topic, but important to understand. So the CPU cache, this is a slightly harder topic because you may not have heard of cache before. Cache, and you can see I pronounce it cache, that's how you should pronounce it. I always used to start off by calling it cache. That's not how you pronounce it. It sounds a bit stupid if you say cache. It's actually cache. So cache in computing is a type of memory that stores frequently accessed instructions and data so that they can be quickly accessed. Basically, cache memory is very fast to access. So you have a small amount of cache in your computer in various different things: browser cache, processor cache, and hard drive cache, different types of cache. You have them so that frequently accessed instructions can be accessed quicker than they would be if they were stored elsewhere. So a web browser does also use cache, like I mentioned. So for example, a commonly accessed website such as Google, so if you access Google a lot, which I do, Google will have its details stored within a browser cache, so if whenever you request it, it will load almost instantaneously. You may want to try this. Your Google page may load really fast because you access it so often and it's stored in this fast type of memory. So, like I say, a processor has a cache, and these contain small blocks of data that are frequently accessed in order to save time. So, more cache basically means a greater performance, and this is because a larger cache means more data can be stored, which can later be accessed quickly, which helps for long-term performance. The cache is instead of having to interact with memory, processor has to interact with cache, which is right next to it, and that is obviously quicker to access, and the memory is designed so that it's really quick to access. So if you have a large cache, more data can be stored in it, which improves performance over the long term. So I've talked very quickly in this video. I have to have some water. There's a lot to cover. Like I said at the start, you may want to go over it. I hope I've been as clear as possible. Any questions, please feel free to ask me. Yeah, thanks a lot for watching, and I hope to see you in the next video.